topic is curves on Earth and beyond. Beyond in the sense in space. There are so many curves we could see in our everyday life on Earth as well as in space. Okay, some of the interesting things we will be discussing about. It is not just speaking, it is a discussion. What we will do here, at the beginning of the presentation, we will give definitions, equations of curves, what are the formulas involved, what are the properties satisfied by each curve, and important results. After explaining all these things, we will be asking questions to the audience, what you have understood, and I will ask some formulas and other things. But it would be a very boring thing, no? So I am not going to do all these things, don't panic. Our presentation will not be in that sort of presentation, it will be enjoyable. Here, I will be asking questions and I will be answering. I will not be asking questions to you. Okay, so the questions which I raised when I was reading all these things from the internet, from the books, from magazines, or so many sort of resources. So I enjoyed them. I wanted to share all these things and I wanted to convey the enjoyment, that happiness to all of you. Okay, so it will be a very nice thing. Some questions, very interesting questions, we will ask and we will answer. And you will have only one question. Is it? That will be the question you will be asking. Whenever I am asking a question and I am giving the answer, your mind will ask, is it unbelievable? I didn't know about that. It's a new information for me. All sort of things. I hope, I expect your mind will ask yourself. And for some information, your mind will say, it will wonder, it will reflect, it will say, wow. Is it? Wow. It's very good to know that. I didn't know that. So that is the sort of questions and answers you will have. I will have some questions and I will answer them. Okay, dear participants, we will enjoy the session, just 15 minutes. Actually, I prepared this for 1.5 hours and cut short to 15 minutes yesterday. Okay, first question. How much Earth can we view? We are all living on Earth and we are viewing the Earth. What we see here is Earth. But how much we can view when we are in different places? On Earth, above Earth, beyond Earth. Whatever we view will be mostly in circular shape. Okay? So, if we go to the beach, see the ocean or sea, we will see only water. At the end of the water, we will see a line, horizon. From there, sky will start. Have you ever wondered what is the distance between you and the horizon? Anybody knows? The answer is there, 5 kilometers we can view from the seashore till the horizon. If you are atop Burj Khalifa, how long you can view? The circular view, you have to turn around. Okay, but the radius will be 103 kilometers if you are atop Burj Khalifa. I enjoyed this in the new year of 2020. So it was. Then from Mount Everest. From Mount Everest, if you are looking around, still you have to look around. You have to turn your head or eyes or your body to see that horizon, that circular shape. It will be 336 kilometers atop Mount Everest. That is, that radius, the circle with that radius you can view. If you go a little bit further, that is around 11 kilometers or 10 kilometers, you are in a commercial passenger plane. if you are looking outside the window. You will be definitely looking at the horizon. You can view the horizon. What will be the radius of the circle? 369 kilometers, a little bit higher, because Mount Everest is 8,848 meters, 8.85 kilometers. Commercial passenger plane, 11 kilometers. So a little bit more. If you are in the International Space Station, you can view 1,600 kilometers radius. Still, dear participants, you have to turn around or you have to go to places, other windows to see the complete circle. Okay, but when can we see the whole Earth? Our angle of view is 135 degrees. So the Earth, the whole Earth must come in and the purview of 135 degrees. That can happen only after you you go away 6,000 kilometers or more. Or 10,000 kilometers will be ideal. If you go above 10,000 kilometers, you can view the Earth in its complete sense. But remember, dear participants, it is not even 50%. It is less than 50%. If you are lucky enough to go to moon, this will be the scene you can see from there. It will be 4 times bigger than the full moon you see from our Earth. Okay, because moon is 1/4 of the size of Earth. So this will be the situation how we can view the Earth from Earth, above Earth and beyond. Second question I asked myself, I enjoyed myself, is why are planets spherical whereas their orbits elliptical? When we directly see, we can only see them just like a star. Other planets we can only see like a star. But if you are using telescopes, you can see them as planets, right? But why are they spherical? Can anybody tell me? See, all the planets are spherical in shape, but some planets have rings, but the planet is spherical because of the mass. All celestial objects are not spherical. Okay, only the planets are spherical, or dwarf planets are spherical. They must gain certain mass to become spherical because of the gravitational pull. Okay, these planets have gained enough mass for gravitational pull, and so they become spherical. Why are their paths elliptical? I hope everybody knows that planets orbit the sun in elliptical path. Why is that? Can anybody tell me? Why not parabola? Why not hyperbola? Why not a straight line? Is it possible for our Earth to go straight line, not elliptical? It is possible. See, the first one is straight line. That means any object with enough speed, and very long distance, far away from the sun, they will go in a straight line. They will not be, if they are not under the influence of the sun, they will go straight line. It will not be affected. Then, if the speed is a little bit less, and if we are a little bit nearby the sun, they will take hyperbola. Then, still slower and nearby, parabola. Then, ellipse. We are in that category. Our speed and our distance from the sun, it is eligible for elliptical orbit. Otherwise, we may be in hyperbola or parabolic orbit or other things. Why are satellites not falling down? Many people have asked me, birds can fly, why can't we? How satellites are not falling down? They have weight, they are under the influence of the Earth, then why? We can make experiment. People have made experiment. When we are putting a ball or marble vertically, it will fall vertically, right? If we throw, it will go to some distance, but it will anyway fall down. Satellites are not falling down because of their speed. They have to achieve certain speed to orbit the Earth in an orbit. Okay, that is the reason. Can we send a secret message without using mobile, without shouting when we are here? When we are here in a gallery or in a room or somewhere, I will speak here without mobile, without mic, anything. Others should not hear it. Another person whom I want to convey the message, only he or she has to hear it. Is it possible? Possible, but not in all places. Where? Only in the whispering galleries. Whispering galleries are ellipsoidal galleries. Okay, with your focus. Maybe everybody knows that yeah, an ellipse has two focal points, right? So at one focal point, one person has to sit and speak. At the other focal point, the other person has to sit. Only he or she can hear what you speak. Other people cannot hear it. It is one of the wonders of construction, building. There is one whispering gallery in India. There are many galleries all over the world. Can we treat kidney stone without invasion, surgery, without keeping the knife, without cutting the body? Can we treat kidney stones? Kidney stones cause a great pain because the crystals are very, very sharp. We can do that using lithotripsy treatment. In the lithotripter, the device, an ellipse is used. The laser beam is passing through the ellipse and reflecting, and it will be placed on the body of the patient so that the laser beam exactly goes to the stone and breaks it. The stone will be broken into sand like the sand particles, and it will easily come out. So no pain, no surgery, nothing. Okay, so ellipse is used there. And the fastest movement, this is children's play. We are making a ball roll down from your top to the bottom. Various paths are there, straight line or cycloid or parabolic, elliptic, 6th degree, 4th degree curve. Which one will become the fastest? If you can see, maybe it comes in a loop. Which ball comes faster? The second one from down, right? The one which is moving through the cycloid, that is faster. Not the one with slope, not the one with 6th degree polynomial, not the one with parabola or circle. Okay, the cycloid, that path will take the ball faster. We are almost at the end of the presentation. Maybe one more question. Can we ride smoothly in a bike or car with a square wheel? All wheels we know are round, right? Circular. In case we have square wheel, can we ride the bike or car? We can ride, but it will be bumpy, right? You cannot sit there for a long time. But is it feasible? It is feasible when the road or path on which we travel is in the shape of catenary. You can see there. The cycle with square wheels, it will be very smooth. You will not believe it, dear participants. It will be very smooth. If the path is catenary path and square wheel exactly matching the length of arc of the catenary, it will be a very smooth ride. You can see the line, it is completely horizontal. Very smooth ride it will be, and it is being used in a certain environment. Okay, a certain path it is used. Not only catenary and square, see, you can see different types of wheels and different types of paths also. All will work very fine. Maybe the last question and answer. Can I thank you until we meet the next time? Thank you very much. I hope you enjoyed, because I haven't asked a single mathematical question. I haven't told you any mathematical formula, any mathematical definition. I restricted myself because I know everybody, most of you are students. I wanted you to enjoy the session, so thank you very much. Any questions you can ask, please.